Welcome to Lesson 3. This lesson is going to be a mixture of technical and theory, covering both cinematography basics and how to achieve those basics in Unreal. These are some of the most important skills for you to master. You may have some of the best character models you can get your hands on sitting in high quality environments, but they aren't going to look good if they're not lit or framed correctly. Lighting in particular is the main element that can elevate a good shot to a great one, and sometimes the changes required can be incredibly subtle. There is no one way of achieving effective lighting. Every situation is going to call for different solutions, but there are well-established guidelines, and that's what we'll be going through in this lesson. Here's what else we'll be covering: the different lights in Unreal and their settings, ray tracing, the Unreal cinematic camera and its settings, importing characters, setting up a sequence, moving the camera, basic camera shots, basic 3-point lighting, and building a basic camera shake. Let's get started. We'll open our original project called Setup, but we won't go to our previously saved level. Let's just work on the main screen for now and set up a few things so that we can better show off our lighting. Head up to the Add button and we're going to drop a sphere into the middle of our scene. Then we're going to duplicate it. There's a few ways we can do this, but probably the easiest is just to choose the Translate or Move button, then hold down Alt and left-click drag from any control handle. Now you should have two spheres. Let's go to the Starter Content folder you added in the previous lesson. Inside the Starter Content folder, we're going to navigate to Materials, and then on one sphere, we're going to change it to M Metal Chrome. This is as easy as dragging and dropping the material onto the sphere. In the Details panel, you can see the Material panel for the sphere, and you can also drag and drop it into here for the same result. Choose a different material for the other sphere. I went with something simple, like this basic floor. And now, a very brief intro to material editing, before we cover it in more detail in future lessons. If you double-click on the chrome material, you'll see this window come up. These are the settings for this particular material. Depending on your material, these settings can be very simple or very complicated, but this one's pretty straightforward. We're just going to change one setting. Plugged into the result node of the material, or the final result of all the settings, you can see two numbers, or constants, which are setting the strength of both your metallic and roughness. Metallic is set to 1 or full strength, which is good because we're dealing with a metallic material. Dropping that down gives the material a more plasticky look, so we'll just leave that alone on 1. The constant we are changing is roughness. Roughness dictates how shiny and reflective an object is, and we want this to be a little shinier than it is to show off our lights and the reflective surface. So we're going to set that to 0.1. Click on Apply, Save, and then quit out of that window. Great! You just edited your first material, and now we can see one sphere and the environment reflected in the other. We're going to delete everything except the spheres and the floor until we're just left with a black screen. Now we can start lighting. Just a very quick word about lighting in Unreal before we dive in. Unreal, as you've probably gathered by now, is an incredibly complicated piece of software, with lots of stuff going on under the hood. Usually this is out of sight and not something you have to worry about, but there are occasions where certain kinds of lighting doesn't play well with certain settings, and I'll do my best to highlight those as we come across them, along with potential fixes. Okay, let's add our most basic kind of light, the point light. This is essentially the equivalent of a bare light bulb, which sends out light in all directions equally. Let's take a quick moment to demonstrate again what the virtual shadow maps are doing. It's on at the moment, so as you can see, using the source radius, we can alter the scale of our light, which either graduates or sharpens our shadow. Using the G key, we can make sure that we have our control widgets on. You can actually see a yellow control around the light, which grows or shrinks to show how big the light actually is. I don't tend to adjust this too high, as you can get some undesirable results. If I go into the project settings, search for shadows, and switch back to basic shadow maps, then we're left with just sharp shadows. And this setting doesn't affect the shadows anymore. In terms of expense, with virtual shadow maps on, it looks better, but is using more processor power. And off, it doesn't look as good, but is cheaper. There's no right or wrong setting, it totally depends on what is going to work best for you and your project. Let's go through all the settings for this light in the details panel. Most settings are shared across all lights, others have their own specific settings. Heading down the list, first up we have location, rotation and scale. Rotation and scale have pretty much no effect on a point light, but location lets you move the light around in the scene and maybe do some fine tuning. Mobility is an interesting one, and it's where we get into the question of baked versus movable lights. Baked lighting, in a gaming sense, is the practice of pre-computing your lighting for a given level. It can increase performance in gaming, but for digital filmmaking, where you're going to be wanting to constantly change and tweak between shots, you may just want to use the more intensive but far more flexible movable setting for all your lights. Just be aware that the more lights you add with this setting, the more it's going to slow your computer down. Intensity changes the brightness of your light. Easy. Light color is a simple color picker, and attenuation radius is the sphere of influence that the light has, once again visible with this mesh. We've covered source radius, so next up is soft source radius. If you look at the light reflected in our sphere, you can see that it adjusts the amount of glow around the light. Source length does as the name suggests, and changes our light bulb to a light tube. You can adjust the temperature of your light for some nice looks, from warm to cold. These two settings generally stay on, otherwise your light won't work properly, but there may be some instances where you want a light source that doesn't actually cast a shadow. Indirect lighting intensity is once again pretty self-explanatory, and increases the amount of light bouncing around from this particular light. Volumetric intensity increases its glow in haze, which we'll come back to when we turn our fog on. After that, we get into controls that you can generally leave on their defaults, except for a few where it's good to know how they work. Transmission is for scattering light through waxy or slightly translucent surfaces, and we'll have a look at that shortly when we bring some human characters in. Volumetric shadow is good if you want an effect like a hazy light being blocked by a mesh, like a misty light shooting through Venetian blinds or something like that. But this is where we run into our first instance of some settings not playing well together. We can take a look at this by adding an exponential height fog to our scene and setting it to volumetric fog. Turn the fog density right up, and then on our point light, reset all the parameters back to default using these buttons. Then set the intensity to 30 and increase the volumetric scattering intensity to full. On our point light, do a search on ray tracing until you find cast ray traced shadows and set it to disabled. Then we want to switch volumetric shadow on. Now, when we move it around behind our sphere, we'll see that the haze gets cut off for some nice lighting effects. Here's the volumetric shadow on and off. We can switch ray tracing back on, but now our volumetric shadows don't work again. Apparently these two settings aren't compatible yet, but you should be able to come up with a fix where you can switch ray tracing off on the particular light that you want volumetrics on, and then just position it so that it doesn't cast any unflattering shadows. As a final note about ray tracing, it's true that it will always give you superior lighting and shadows, but as mentioned before, it is expensive. If you are finding that your system just can't handle it, or you're always getting out of memory errors, then you always have the option of going into project settings and switching it off. You'll have to do a restart and the shaders will need to recompile, but your project should run a lot faster. Full confession, I had finished about 3 animated shorts before I'd even properly figured out what it did, so it's not a deal breaker. You can live without it if you need to. Let's switch off our point light and add a spotlight. Using the G key to make sure we can see the control widgets, you can see the cone of this particular light and angle it towards our sphere. Pretty much all the controls are the same as they were for point light, except for these two, which control the width and fall off of the spotlight cone. You can also increase the volumetric scattering and intensity for that classic misty spotlight look. Hide your spotlight and add a rectangle light. This is possibly your most powerful lighting tool in terms of adding subtle directional lighting. The custom settings for this light are width, height, barn door angle, and barn door length. For those of you unfamiliar with the term, Barn doors are the flaps on the sides of film lights used for cutting and directing a light source, and these work in exactly the same way. You can create all sorts of useful lighting sources with this tool, from overhead lighting, a soft fill on the side of a subject that won't spill into the rest of the environment, or even a 1960s Captain Kirk style bar of light over the eyes of a character. The last two items are HDRI backdrop and sun and sky. HDRI backdrop gives you a ready-made wraparound environment to drop your models into, along with built-in lighting. And as you can see, the environment is also reflected in the sphere. There are tons of sites where you can download free HDRI backdrops of many different environments, and they can be a lot of fun to play with. Once you've downloaded them, just import the .hdr file into the folder of your choice. Then you should be able to choose the new cube map in the HDRI details panel. Sun and Sky is a tool for replicating the sun's position on exact days, dates and times of year. I can't say I've ever used it. I imagine it's useful for simulation games, things like that. Now you may have noticed that as nice as this lighting looks, it's all quite flat. Maybe you're wondering how to get that really nice depth of field you've seen in other Unreal videos. To achieve that, we need to look at the cinematic camera. Go back up to Add, choose Cinematic, and then Cine Camera Actor. You'll see a new window on the project that shows you the view through this camera. To make that full screen, go to Perspective, then choose Cine Camera Actor 1. You can now move around with this camera exactly like you would normally in the project window, with the added bonus of depth of field. Over in the Details settings, there's a few basics to look at straight up. You have your basic location settings, and mobility should be set to movable by default. You can set the camera to always look at a particular object or character, but I haven't really used this setting. I imagine it's more useful in third-person games where the camera has to follow a character. Film back is the frame size and aspect ratio of the camera, and there's a few different options here. I've become a fan of 35mm Academy. We'll leave the lens settings on their defaults, except for the squeeze factor, which we'll set to 2. As you can see, that's made a pretty dramatic difference to the framing, but it's also turned our lens into an anamorphic lens. This shows up really well if I adjust the focus, and you can see that our out of focus highlights get that really nice oval shape that us filmmakers love so much. This is a really welcome addition in Unreal 5.1, and you guys have come in at just the right time to take advantage of it. Let's head down to focus settings. The focus debug plane is something you'll be coming back to again and again, as it shows you which parts of your frame are perfectly in focus. Sometimes something might look sharp in a smaller window, but soft when you get it onto a larger screen. So this is a very handy tool to have. You probably want to switch on smooth focus changes as well. You can also choose to track a particular object and have them in focus all the time, but I prefer to stay on manual. Focal length is the zoom setting of your camera lens, and aperture won't work just yet, but we'll set that up shortly. That's probably enough for you to start having a play. Before we go too much further, let's import something that's a little more interesting to frame up than a couple of spheres, and go through a few camera shots at the same time. Open up the Epic launcher, go to Marketplace and Permanently Free Collection. Then, in the search tags, choose Character and choose this stylized character to download. When it's ready, add it to the project setup. Then we'll go back to our Unreal project and load up our level setup where we saved our lighting setup previously. You'll see that the folder has been added to your project. Navigate to Models and Remade Characters, then drag and drop these two guys into your project window and have them face each other. Once again, good practice to highlight them both in the outliner, then move them into a folder called Characters. These guys are good to practice with because not only are they free and low poly, meaning that they don't have many polygons in their meshes, they're also very well modeled and textured and light really well. So let's have a play. So imagine these are your actors and they're having a dialogue in the scene. What are a few different ways you could frame up this dialogue? Add a cine camera into the scene and choose it in perspective. Now you can just experiment, moving the camera around these characters and framing up shots. There are a few basic guidelines to be aware of with framing though, so let's go through some of them. The first one is the rule of thirds. If you imagine your screen divided into lines horizontally and vertically, then generally you want your character's eyes to rest around the top third, rather than right in the middle of the screen. Similarly, if they're talking to someone or looking at something, we want to allow some looking space on that side of the screen. Sometimes it can be a very small adjustment, but it can make all the difference. This framing is known as dirty. What that means is that the character facing away from camera is still on screen, and is a far more interesting composition than just one character talking. You can experiment with changing the distance between your characters and adjusting the focal lengths for different looks. Remember though, that people rarely stand facing each other for long periods of time when they're talking. Experiment with different positions for your characters. Have a look at some of your favourite movies and TV shows and see how they set up their dialogue scenes. Key moments of dialogue might even require their own framing, and this is where having a simple storyboard might be handy. If you can't draw, then even just moving the camera around and taking screen grabs of preferred compositions is useful before you get into the actual business of animating. Framing up dialogue scenes in an interesting way is one of my favourite parts of animating in Unreal, and I hope you all enjoy the freedom it allows as well. Now we've got the camera up and running, let's introduce some dynamic lighting into the scene. First up, let's delete all the atmospheric lights we added before because I want to show you a neat trick. Go to Window and Environment Light Mixer. Then click on all 5 of these boxes. Boom! You just created your environmental light with a few clicks, and that's something you should get used to doing every time you make a new scene. Highlight your new assets in the outliner and move them into the Environment Light folder. Let's switch our bloom and occlusion back on, set sky to real time, set fog to volumetric, and we're ready to go. Using Ctrl L, this lighting is looking pretty good all by itself, but I think we can add some enhancements. And that's where we're going to get introduced to the 3 light setup: back, fill, and key. Switch off your directional light so that you have a black screen, and add a rect light. We're going to add some nice sharp backlight to your subject. Backlight is basically the magic ingredient in lighting. It separates the subject from the background, it enhances the contours of the model, and overall just looks better. So we want to accentuate it as much as possible. If you move your light into position behind the character, you should see that you're getting this really nice glow through the ears and the skin. This is the transmission I was talking about earlier, and it occurs when your models have subsurface scattering activated. What is subsurface scattering? Well, imagine shining a bright torch through the bottom of your hand. You would see some light come through the top, and it would be scattered through your hand. It would look like your hand was glowing red, and that's exactly what's happening here. The light is being scattered through the skin. Now we're going to add another rect light to work as our fill. Basically, this can be a very soft, subtle light that fills in any harsh shadows. In the real world, if you're lighting, this may not even be an actual light. It could be somebody holding up a reflector to bounce light back onto a subject. Now, switch your directional light back on, and that's going to be your main light source, or key light. Let's move it into a position slightly behind our character so that it matches the backlight. We can switch these various elements on and off to see if we like what they're doing and tweak positions, rotations, and intensities until you achieve the desired result. Let's go over a few more camera settings to really bring this to life. If you choose the camera and scroll down to lens, you'll see a lot more settings. I'm going to show you my basic setup, but once you know what these do, you can experiment to find your own looks. Bloom adds a glow to the scene for a really nice soft focus look. You have 2 methods, standard or convolution. Convolution only affects the highlights, whereas standard affects the whole scene. I usually go for standard at about 4. We want to set our exposure metering mode to manual and exposure compensation to 10. Now that we've done this, if we scroll up, we'll see that our aperture is working, which is how much light the lens is letting into your camera. The lower this number, the more open the aperture is, and your shots will have a very shallow depth of focus. If I increase it, you'll see that the scene becomes darker, but both characters are sharp. You can combine this with camera exposure for various focus effects, like a super shallow depth of field close-up. Chromatic aberration is a really nice one for adding a touch of realism. I usually like to set this to something pretty subtle, like 0.4. You can add a dirt mask to your lens for dust on the lens effects, but I can't say I've ever made use of this feature. For anyone familiar with cameras, we have some more options here for fine-tuning lighting, but I personally prefer to leave them on the defaults. Local exposure I generally leave alone, but I do like to set detail strength to 1.2 for a little bit of additional contrast. Have a play with these settings and see what you'd like the look of. Lens flares on or off is a personal choice, and there's various settings here for controlling their intensity, size and color. I personally like a little bit of vignette around my frame, about 0.5, and we can leave the depth of field settings as they are. There's a ton of options below for color grading your shot, but my personal preference is to just render it out as neutral as possible and do most of my grading in Premiere, but that's just me. Your mileage may vary. Finally, find film grain and set it to something like 0.2. This adds a very subtle amount of noise in your picture for added realism. So, these static shots are all well and good, but what if we want the camera to move? A nice slow tracking shot, a reveal, a pan, a tilt, even a dolly zoom. That's where we need to create a new sequence. Go up to this button and choose Add Level Sequence. This is going to appear in the content browser with this icon, and also as a new tab. FYI, this little asterisk means that this particular item has had changes in it that haven't been saved yet. So if we hit Ctrl-Shift-S, which you should get into the habit of doing anyway, it goes away. Now, your sequencer timeline looks like this, and it all works around keyframes. We can demonstrate this by taking our camera from the outliner, dragging and dropping it onto the timeline. From here, we can adjust the aperture, the focal length, and the focus, as well as moving it around the environment. Let's say we want to do a nice dramatic push into this character. Using the arrow keys, we bring our camera out to its starting position, and then highlight Cine Camera Actor on the sequencer. Make sure your timeline marker is at the beginning of the sequence, and hit S key, which creates a new keyframe in the Transform menu. Now, move your timeline marker again to the end of the sequence, defined by these little red and green in and out points, and hit S again. If you scroll through, you'll see that you have a camera move. Want it to be longer or slower? Click and drag on this number to extend your sequence and move your out point. Then click and drag on your final keyframe and the camera component bar to match. A very, very important thing to remember is to also drag out the camera cuts window and make sure this extends right between the in and out, because Unreal will only render the duration of this clip no matter where the out point is. This has caught me out many times. Want a faster camera move? Grab your final keyframe and move it closer to the first one for a 70s style crash zoom. Now, by default, Unreal places what's called handles on each side of this movement, so the camera eases in and out and doesn't just stop suddenly. Most of the time this is desirable and what you want, but there may be times that you want to switch that off. To do that, we can click on the Curve Editor, and then the Cine Camera Actor, which shows a visual representation of our move with a nice gentle curve. If we want it to stop suddenly, then choose the final point, click on this button, and choose Linear. You now see that the camera comes to a sharp stop, and if we view it on the timeline, it looks like this. You can always switch the curve back on, or experiment with different shapes. Just next to the Curve Editor is the FPS, or frames per second. This is going to be different depending on your location. In the USA, it will be 30 frames per second. Here in New Zealand, I use 25 frames per second. If you want to render out footage that you know you want to be in slow-mo, then render out at a higher frame rate, like 50 or 100, and then you can slow that footage down in your editing software for this kind of effect. As our camera moves, our focus changes, and this is where the focus plane comes in handy. We can use keyframes on our focus distance to set 3 or 4 various points as the camera moves and make sure that our subject always stays sharp. Once again, every time you want to create a new keyframe, just hit S, or you can press this button on the timeline. Now, we've got our camera moving in, but our actors still aren't doing very much. We can alter that by dragging them both into the sequencer as well and adding some animations. The important thing to know about animations with characters is that the animation needs to be matched to the particular skeleton that is being used in that character. And skeletons come in many different flavors, from character creator to Mixamo to Unreal and beyond. These particular characters are using the Unreal default skeleton and come with a few preloaded animations, which we can access by clicking on Animation, then choosing one from this list. For the character facing the camera, let's choose Third Person Idle. This is a looping animation, so you can click and drag it out to the duration that you need it to be. We can do the same for the other character, and then by right-clicking on the animation, we can change the play rate slightly, so that both characters aren't doing the same thing at the same time. We'll be going into far more depth in animation in a future lesson, but let's look at one more thing. We can also blend animations for characters by adding another track and changing the animation's weights to decide which one is more predominant. The Blend Shapes animation showcases some of the expressions available to these characters, manipulated with preset settings called Blend Shapes, which we'll also go into later. This is looking pretty good, but we can enhance it still more by adding a subtle camera shake. Create a new folder in the content browser called Shake, and right-click, add Blueprint class. Inside that window, search for Shake, choose Default Camera Shake Base, and call it Shake. Double-click on it, click on Compile, Quit Out, and double-click again. You should now have access to the Shake settings. We want to leave most things alone except for the X, Y, and Z amplitudes to start with, which we'll set to 2, and the duration, which we'll set to 50. Compile and quit, then Ctrl-Shift-S to save. Now if we go back to the sequencer and camera track, we'll see that our shake can be added to the timeline and extended out. You can weaken or strengthen it by right-clicking and changing the play scale. Now, our camera move has a little bit of organic motion on it, which can be as subtle or as strong as you want it to be. Double-click on the Shake blueprint and play with some of the settings to see what effect they have on your timeline. The great thing about the shake is that now that you've made it, it can be added to any new sequence in this project, or even migrated to a new project using the same method we used in the previous lesson. There's two final things to look at in regards to moving the camera, and they're both pretty fun. Replicating the effects of equipment that can be prohibitively expensive in the real world. The camera crane and the camera rail. The camera crane is great for creating sweeping establishing shots that can start up high and end down low, and the rail is your built-in dolly system that can be as long or as short as you like. Let's look at the crane first. Go to Add, Cinematic, and Add Camera Rig Crane. As you can see, this drops an actual crane into our scene, but this is for visual reference only. It won't be rendered out at any shots. Then add a cine camera actor. Let's create a new sequence called Movement, and then drag both of these elements onto it. On the camera, click Track, Attach, and choose the crane. Then line the camera up with the end of your crane, as it might look in the real world. Now, if we move our crane, the camera moves with it. Also to make sure your camera bar is extended for the full duration of your clip. Moving the crane is pretty easy, but first we need to add the required controls to the timeline. On the crane, click Track, and then under Properties, add Length, Pitch, and Yaw. This is where locking the camera onto a subject can be useful. So let's go ahead and switch Look At Tracking on, and then use the eyedropper to select one of our actors. The camera will now look at that actor wherever it moves, but you won't see the full effect until it's animated. Move your timeline marker to the head, select Crane Yaw, then rotate it to your starting position. press this button to add a keyframe. Then move to the end of your sequence, adjust your yaw, and add another keyframe. When you play the sequence, you should see your camera do a big sweep across your subject. If you want to add a bit of height, go back to the beginning, use this Jump to Previous Keyframe button, and increase the pitch, then add a keyframe for that. Then move to the end and add another keyframe. If you click this button, then the sequencer will automatically add a new keyframe every time you make a change, but this only takes effect if there's already at least one keyframe already, so you still have to manually set the initial position. You can do the same with the arm length as well, exactly the same process. You can see the shot here, and if we move out a bit, we get a pretty good idea of exactly what the crane is doing. That's a lot of fun, and you can set up some pretty dramatic shots. Now let's look at the camera rail. Go ahead and delete the crane from the timeline and then from the outliner. And also delete the camera from the sequencer, so we're starting from scratch. Then go ahead and add Cinematic Camera Rig Rail. This will drop this little device on that looks like a short track with a white dot at the end of it. Place the track where you want its initial point to be, then Alt-click on the white dot and drag it out to extend your track. If you Alt-drag on the end again, now in a different direction, you can put a curve in your track. Every time you Alt-drag on a white point, you can add a new control point for further track refinement, until you have a full circle around your subject. You can even raise or lower some points of your track for a real roller coaster effect. Once you're happy with the shape, drag and drop the rail onto the sequencer, and under Track, add Current Position on Rail. Then, add your camera into the sequencer and attach it to the rail as you did with the crane. Then place it in the initial position, you can choose an actor to track or add a transformed track to the camera and move it manually, however you prefer. And extend these bars as required. As with the crane, set the timeline marker to the head and add a keyframe. If you've left Auto Keyframe switch on, then it should automatically add them from this point. Move the marker to the end of the track, and then increase the number of the current position. Now, when you play it down, your camera should take a little ride through your scene. You can speed up or slow down individual parts of your track by adding new keyframes and changing the rail position, then adjusting the distance between keyframes. You can also still adjust the individual control points of the track until you get a movement you're happy with. Okay, so that's a lot to go on with. We won't look at rendering out just yet because that's a whole other lesson with a lot of quirks of its own. Once again, take a pause, experiment, and play. The first few lessons should have already given you a lot of knowledge to start playing with, but once you're ready to know more, I'll see you in the next lesson.